All right, you can see that?
Yes.
Excellent. So welcome everyone to an RASC Montreal Center public event. We are very happy today to talk about Comet Neowise, which has been gracing our skies for this month of July. This yet another month of COVID pandemic measures that has stuck a lot of us inside most of the time. So it's nice to actually have something in the night sky to enjoy. So before we get to David's presentation, I wanted to talk to you a little bit about what RASC Montreal is for those of you that are new to one of our events. The RASC Montreal Center is part of a nationwide group of amateur astronomy and hobbyists. We are 4,000 plus in 29 centers across the country, and the Montreal Center is one of the oldest ones. We are 100 plus years old, and we have about 170 members of all ages. Overall, throughout the year, we have public events and talks, we have clubhouses, we share a newsletter to share some of our observing experiences. And at the moment with the pandemic, we were one of the first groups, actually amateur societies, to just jump online. So thanks to the dedicated efforts of some of our members, Carl Jorgensen, Nicole, David, Detlev, Ben, myself, we've been having bi-weekly events on Zoom for members and at least monthly events for the public to continue sharing our love of astronomy and of space sciences. So David is actually coming fresh off of an incredible April, May, where he gave us 3 content-filled presentations on space exploration from North America, from Canada, worldwide, where we're going when we come back to the moon later. And it's fantastic that he shares so much of what he learns from his hobby with us. And so oftentimes, especially when there's not a pandemic measure, we have observing nights that we open to the public, and then members observing nights that are both at the Bellevue Observatory in Morgan Arboretum and at a dark sky site that we have down close to the US border called Woolly Woods. We also do partner events with the Planetarium, with the Cosmodome, with other societies here in Montreal and across Canada. We actually are hoping to partner with a few societies through the fall for some very cool events that are coming up that I'll talk to you about in a moment. You can always find out what we're doing by visiting our website, and the information for our website is there, and it'll also be on this recorded talk once it's up on YouTube, which should be sometime tomorrow. We have a library at John Abbott College as well of astronomy resources that members can take out and that other individuals can come and take a look at during the year. Now, our National Society has weekly events throughout the year, and right now one of the big things that we're doing is actually a Explore the Universe certificate program that's happening online. A couple of times a month, they're going through different targets that you can look at with naked eye, with binoculars, with small telescopes, and then with larger telescopes. We also have other centers that are sharing their events on our national YouTube page. Our own next event is actually going to be on August 8th. It's part of the Perseids meteor shower. So we're going to be sharing some tips about how to see the Perseid meteor shower, how to observe them, and our past president is going to be sharing some photography tips on how to actually take a picture of the meteor shower in the night sky. But before we get to all of that, tonight we get to learn a little bit about this comet that's gracing our night sky. So David Shuman is one of our longtime board members here at the RASC Montreal Center. He's an avid enthusiast. He's been to shuttle launches. He's been chasing the eclipse. He's written documentaries and filmed them with his friend Paul Simard, who's on the talk with us today and who's our vice president at the moment for the RASC Montreal Center. And David has been out a couple of times looking at the Comet Neowise and trying to capture the photography of it to share with us. And then he's also been part of our discussions every couple of days about what we've been seeing in the night sky. So he's going to now share with both members and the public what we've learned about the comet and what it is that makes comets so special when they come by Earth. So I'm going to go ahead and stop sharing now, and I will invite David to share his screen. Are you able to share?
It's warning me that I can't. Host disabled participant sharing screen.
There you go. Now you should be able to.
Okay, let me try that again. I want to make sure I'm on the right screen. Do you guys see the title slide right now?
Yep, perfect.
Okay, so that'll be my main monitor. Hi, like Karim mentioned, my name is Dave Shuman. I'm a longtime and proud member of the RASC Montreal Center, and I think it's my 28th year serving in one way or another on the board. 27, 28 years. It's been a while. Just like the comets, it's like I'm orbiting and coming back around the sun again. So I've been invited to give a talk tonight about something that's really special to many of us, and that's these lovely visitors that grace our skies from time to time. And as comets are, well, predictable and unpredictable in how they display themselves, predictable in that we know the math behind it, but once in a while we get a treat that comes along, just like Comet Neowise right now, that during the darkest times that we're going through this year with the COVID situation around the world and a lot of sadness and bad economy and people getting sick, there's kind of a glimmer of hope. And unlike in the past when comets were looked at as bad omen for telling of wars and problems, we know better now, and comets are just a beautiful delight to take our minds away from our earthly troubles right now. So Comet Neowise was the right medicine at the right time. I'm going to go ahead and move to my next slide. 1 second. Okay. So I'm bringing up this talk is what is a comet? How are comets discovered? Famous comets, not all of them, of course. About Comet Neowise, a gallery from Montreal members, how to observe Comet Neowise, and how to photograph Comet Neowise, and then any questions and answers you might have about this subject. I'd like to leave the questions for afterwards if it's possible, and then we'll have that informal session. We can talk about everything to do with comets. So to move along, I'm going to say, well, what is a comet? Well, these quotations come off the web. So here's a beautiful picture taken of a comet out at the comet itself by spacecraft. And a comet is simply an icy small solar system body that when passing close to the sun warms and begins to release gases, it sublimates. And this sublimation produces a visible atmosphere or coma, and sometimes also a tail. These phenomena are due to the effects of solar radiation and the solar wind acting upon the nucleus of the comet. So in other words, our solar wind, the pressure of the emitting energy from the sun, kind of lets the comet bloom or blossom by having the dust trail behind the comet. Comets are made out of a mix of rocky components similar to what makes up the Earth's mantle, dust and ices. Ice just doesn't mean water ice, but it also volatile components like dry ice, CO2, methane, and ammonia, and carbon monoxide. Many of these are the initial building blocks for life on Earth. Complex molecules made out of these fundamental building blocks, mostly hydrogen, oxygen, carbon, and nitrogen. Two molecules that are of particular interest are cyanide, cyanogen, CN, a carbon-nitrogen bond, and a diatomic carbon, C2 carbon-carbon bond. I'll talk a little later about that cyanogen cyanide. Nothing scary about the cyanide. It just has to do with the color. So here's a diagram of the anatomy of a comet. So you have the coma itself, which is that aura around the comet. You have the nucleus, which I'm sorry, but the label's just off here, but this is the nucleus here. The coma is around it, around the nucleus. You have the dust tail and an ion tail. And that ion tail is characteristically viewed as a blue streak of ionized material that's emitting behind the comet in a straight line. It actually points towards where the sun is in relation to the comet. The dust tail, on the other hand, because it's heavier materials, actually gets blown by the solar wind and into like an arcing pattern, depending on how the comet is traveling. So here you could see a diagram of all the chemical components that we've discovered over the years of what's inside a comet using a spectroscopy, sending spacecraft to comets to actually visit comets close up. And of course, with years of observation through telescopes and other systems, we're able to find out what the chemical components of the comet is. And it turns out that comets, like I mentioned earlier, are really the building blocks of almost everything life in our solar system. Many scientists believe that without comets, we might not even have the oceans on Earth and the building blocks for life, which led to, well, to our evolution from billions of years ago, as comets were bombarding the primordial solar system. Here's an artist's representation of early planets being bombarded constantly by comets. So not a very friendly environment around 4.6 billion years with the formation of our solar system and forward. But by repeatedly hitting the Earth, for example, comets, we believe, have delivered a lot of the water that makes up the oceans and the atmosphere, delivered by comets actually impacting with the Earth. And so comets can be seen as a vital connection for life today on Earth. Here's another diagram showing the extent. I mean, it's hard to really explain the scale of what we're looking at. But for example, if you have here on the left the inner solar system with Mars, the Earth, Jupiter, you could see a blow-up diagram of this in comparison to the, let's say, the outer part of our solar system, Pluto, Saturn, Neptune, and then the Kuiper Belt, which is essentially a loose association of icy material around the orbit, past the orbit of Neptune. And this is where Pluto would reside with many other small planetesimals. But then if you pull back much further than that, all of this can be inside of the kernel of something that we call the Oort Cloud, which is, I believe, Jan Oort that discovered that around the inner core of our solar system is a ginormous cloud, essentially, of comet-like material that was formed from the leftovers of the formation of our solar system. And here it says that the Oort Cloud is a spherical cloud of icy planetesimals thought to surround the sun at a distance of 50,000 astronomical units. What's an astronomical unit, you might say? Well, it's the distance between the sun and the Earth. And that's about 97 million kilometers, if I'm not mistaken, give or take. So that's really far away. So these comets, they travel from great distances. Here's a set of images from something called pan-stars. I'll explain that a little later on, showing what I was talking about a little earlier. That greenish glow, and that's certainly no different for Comet Neowise, that beautiful icy green glow, green-blue glow. What's causing that? What is that? So not to get too technical, because it has to do with the ionization of the material, but when you see the green color, it's an indicator of a few things. First of all, of a combination of things, that the coma contains large amounts of CN and C2 molecules, and that the comet is active, it's outgassing and warm, it's close to the sun, and that the potential for a schism or eruption is at its highest. And what's a schism or an eruption is that when that loosely packed association of materials that makes up the nucleus of the comet starts getting warmed up by the sun as it travels closer to our sun, mostly past the Jupiter and Mars orbit. When it starts heading towards the sun on its travel around the sun back out to the outer edges of our solar system, it gets warmed up by the sun, and just like dry ice goes from a solid to a gaseous state without going through the liquid state, and you get parts of the comet breaking apart or shedding, you could say, shedding its skin. And this is what we start to see that gets reflected by the sunlight and lit up as the dust component of the comet. That's the more visible part that we see here on Earth. And if it happens that the comet is of enough density, that has enough material, it's large enough in diameter, and it just happens to be the right circumstance of when it starts sublimating or gassing off, we get to see a really nice show here on Earth. And that's why not every comet's the same, and not every comet has the same period or orbit. So some take thousands of years, and some take just several hundred years. And it's, if I'm not mistaken, it's the Kuiper Belt comets that take several hundred years, under 200 years, is the comets that are more regular. But then we have comets that come from the Oort Cloud that could take thousands and thousands of years to make their sighting visible to us. And we're lucky with Comet Neowise. This is one of those cases. So as of August 9th, in this case, in the slide, there's a relatively close comet, just 70 million miles from Earth, Comet Pan-STARRS C 2017. It has a green glow, and it's relatively bright right now. This is going back a few years. And it's still headed towards the sun. It's being called the Incredible Hulk for its green color. And that's from that cyano, pardon me about that, the cyano ammonia and carbon dioxide, but the cyanide cyanogen, that's it, I'm sorry, is mostly responsible for that greenish glow. Here's another slide taken from some spacecraft approaching a comet, and you can actually see the outgassing here. There's like jets and different parts of the comet breaking apart and just erupting the material and shedding it. So every time the comet passes by the sun, it does lose material. And as it pulls away from the orbit of the sun, back in towards the Oort Cloud or the Kuiper Belt area from where it originated, it's no longer visible. It's not lit up by the sun, or it's very faint. And that's why the comets, there's like millions of comets out there, but we only get to see them when they become really active. So here, the comet data, a dust model, and then the core is visible in this multi-image taken from NASA. So I'm going to briefly say that how are comets discovered? Well, in modern times today, in the past while, comets are mainly robotically discovered with some exceptions. And what I mean by that is they're discovered with orbiting space platforms and a network of telescopes here on Earth. So NASA, for example, has the Wide Field Infrared Survey Explorer, WISE. Guess what? Comet Neowise is a space telescope launched in 2009 to map the entire sky in an infrared wavelength. Its goal was to find objects that had not been imaged before, including very bright galaxies, cold stars, and nearby asteroids and comets. WISE imaged the entire sky twice before running out of coolant in 2010. Keep in mind that for the infrared to work, the detectors have to be cooled down to almost absolute zero so that anything in the infrared is sensitive enough to be imaged. So so to look at near-Earth objects, or NEOs, such as asteroids and comets, for 4 months before being placed into hibernation in February 2011. Less than 3 years later, in December 2013, the telescope was revived to continue its Neowise mission. That work continues today, and of course, as we know, just became fruitful once again. Not to be outdone by the space-based telescopes or ground-based telescopes, for example, the one in Haleakala Observatory, and I've personally been up on the mountain of Haleakala, that's in Maui, and that is a set of observatories used by the US Air Force for tracking satellites and the entry of the space shuttle and other spacecraft. But it's also used for research. So the Panoramic Survey Telescope and Rapid Response System, Pan-STARRS, Located in Haleakala Observatory, Hawaii, consists of astronomical cameras, telescopes, and a computing facility that is surveying the sky for moving or variable objects on a continual basis, and also producing accurate astrometry, that's measurements, and photometry, that's photographic data of already detected objects. In January 2019, the second Pan-STARRS data release was announced. Believe it or not, at 1.6 petabytes, not terabytes, but petabytes, it is the largest volume of astronomical data ever released. So together with the space-based systems like WISE and Neowise and Pan-STARRS and other systems with universities and other institutions around the world, a lot of the sky is being surveyed automatically, systematically, like in sections. And by comparing data from before to a little after, for example, you can see amongst the stars if something moves. If something moves, it won't be in the same position in regards to the background stars. And by comparing this data, you have a very good indicator that there's something possibly like a comet or an asteroid that can be detected. Before this, though, before all this technology, finding comets for hundreds of years and observations going back even several thousand years, believe it or not, was done by very patient, observant astronomers, both amateur and professional. One of the instruments that could help in this is called a blink comparator. And I'm sure David later on with his grace, because I had asked him earlier that if he could maybe give a word or two, not to put him on the spot, but by using a blink comparator, if you take a photographic plate, just like before the digital age, film plates on glass were used to take long exposures of the night sky. And if you would take a plate a few days apart and then put them in this device where you can use this device called a blink comparator, it switches rapidly between the two images, and when you see the difference where the stars remain registered or the same, but then there's one little dot or object that seems to move left and right, it actually gives the appearance that it's moving, or it appears three-dimensional, lifting off of the background stars, and that's potentially something like, you know, like this is how Pluto was discovered by Clyde Tombaugh to confirm. Other comets and asteroids are discovered this way too. And the other way is, and I'm here putting this because I can't talk about discovering comets without talking about our friend David Levy, who is originally from Montreal, now living in Arizona, but a very, very accomplished comet hunter, comet finder, both you know, as an amateur, but also in the professional arena. And very famously with Eugene and Carol Shoemaker, co-discovered Shoemaker Levy 9 way back in 1992, I believe. And of course in 94, as we'll see later in some pictures, the world was stunned when this comet actually collided into Jupiter, reminding us that it's a big universe out there. This is just a list from Wikipedia, for example, of his comet findings and just a small set of accomplishments. So here's an image of David Levy giving a talk about SL9, or Shoemaker Levy 9. As you'll notice by now, many comets, they're usually named by the people that discovered them, or if they're simultaneously discovered around the world, like the people would share the name, but now they're given mostly to those robotic telescope and spacecraft systems that find them, like Neowise and Swift, for example. So before we get to tonight's showpiece, of course, Comet Neowise, I just wanted to give people a taste of past comets, and also the fact that comets, well, they're let's say a couple in a lifetime or a few in a lifetime occurrences. They certainly don't happen every day, that's for sure. And here, so a famous comet is, let's say, Comet Swift-Tuttle. Initially, now the dates I'm putting at the top are either the date that they were discovered or date of first viewing. Because some comets go so far back, they don't have an origin date, just a discovery of their appearance and then the prediction of their period of orbit around the sun. So this in July 16th of 1862 is famous because its dust tail, when Earth collides into it once a year in August, guess what? We get the Perseids meteor shower, and that's that debris from that comet tail that that rains down over our skies in mid-August of every year. And it depends on when the Earth passes through that comet dust tail. If it was a thicker part of the tail that just happened to bleed off at the time, if we go through a thicker part of that tail, we'll get a much nicer show. And some years it's not as nice because there's less material to go through. As the comet passes in its orbit, it refreshes the dust tail and debris. So we can predict with some accuracy the thickness or what to expect in the density of meteors from a comet. So the comets give us two shows, the comet itself and occasionally the meteor shower that's associated with its passing of its dust tail. So here's one. It's first predicted in 1758, the famous Halley's Comet. Now it's Sir Edmund Halley that predicted the comet's return and the calculations that, for example, it would come back in 1986. But it became so synonymous with the word comet, you know, Halley's Comet. That's all we've heard about for so many years. When 1986 came along, companies like Meade and Celestron sold a lot of refractors and telescopes and the little Newtonians, saying, wow, check out the comet. And unfortunately, due to a set of well, geometry and bad circumstances, Halley's Comet was not really a spectacular show in 1986 as people had hoped. Of course, here we got a really spectacular show because the spacecraft approached right up to the comet itself to investigate it. And I'll show you a list a little later on of missions that were sent to comets specifically to get samples and to actually photograph the comet very up close. As you can see so far in these close-up images, most comets are not round shaped, but they're odd shaped. And that further goes to show that they're really a loose clump or collection of icy material rather than an actual perfect sphere. Comet West in 1975, visible throughout 1976, if I'm not mistaken, when these photos were taken. You could see they're a little grainy because back then they didn't have digital cameras like today. It was all taken on photographic film. Nevertheless, look at the stunning beauty. It's almost like a peacock's feather fanning behind the comet. It's just amazing, and I could see why back in the 1800s, well, before the 1800s, the 1600s, people thought of these things as frightening omens because they didn't understand what it was. These can appear quite large in the night sky. There's certainly many moon lengths, let's say, in angular resolution in the sky. So they're, you know, the head of the comet may be tiny, but the tail fans out and takes up a large portion of the night sky. Well, I joined the Montreal Center in 1992, and a couple of years later, I didn't really know too much about actual observing in astronomy, and I along with all our friends, at least here in North America, were treated to a spectacular comet, Comet Hyakutake, which I personally photographed and visited. These are not my photos, these are taken from NASA. But it was the first time that people had better film at the time, better telescopes that could track, and amateurs more and more were taking amazing detailed photographs, even animations. Here in Canada, one member, I think in Ottawa, or Toronto, took a beautiful animation of this comet, very close up, and by taking photographic film frame by frame over several weeks. was able to put together a gorgeous animation where you see detail in the tail, all emanating from the comet head itself. And Hyakutake for me was greener. It had that green head to it with a long bluish looking tail. I'll never forget it, especially in a darker site, but it was easily visible with the naked eye. There was just no question of what you were looking at. You didn't have to look for it or use binoculars. Of course, binoculars and telescopes offered an even better close-up view. So Comet Hyakutake was preceded by 1 year, preceded by 1 year, a comet that everybody was talking about, Comet Hale-Bopp. But Comet Hyakutake was almost like the appetizer before the actual entree. So we had a double whammy when Comet Hale-Bopp was first discovered in July of 1995, but actually made its grace across our skies in the late winter and early spring of 1997. And this was the big one. This one was so visible, I personally thought of it as like the finger of God, because it almost looked like a giant finger was coming down from the sky, just pointing right at the horizon. And even in very light polluted Montreal and Côte St. Luc, I'll never forget, I was taking a road trip to go and photograph Hale-Bopp in Ontario that night. And I gassed up at a local gas station. And even with all the horrible lights, with all the buildings, I could see Hale-Bopp in my windshield while I was tanking up. And I go, I have an appointment with that comet within 45 minutes. I couldn't wait. If it was that visible in the windshield of the gas station in the heart of Montreal, imagine what it would look like when I got to Lancaster, Ontario. And sure enough, it didn't disappoint. I didn't scan them for tonight, but I did manage with many of our members to get excellent photos of the ion part and the dust trail. And the ion part, the gas, the excited emission of the ion part actually was very separated from the dust component of Hale-Bopp, almost looked like a V shape. And these are not exaggerated exposures. These are real exposures that I took from NASA's website, picture of the day. So many of us were exposed to comets and got the comet fever. But then there was a long drought. However, why did I not talk about this before Hale-Bopp? Because this happened a few years earlier, is because this comet wasn't quite visible to us here on Earth that easy. It happens to be a comet that was near the orbit of Jupiter that was essentially torn apart by the gravitation of Jupiter and its forces. And not only was it a comet, but David Levy could attest to this, that when he discovered it, they even thought it was at first an anomaly on the film plates, until after double checking with other people that the Shoemakers and Levy literally found a string of pearls, essentially a comet that had broken apart into cometlets. And what was amazing was it was confirmed later on that it would actually collide into Jupiter in the summer of 1994. So way back in March of 1993, when the comet was first photographed here in infrared by the Hubble Space Telescope, it was known that it would have an appointment with Jupiter and it would actually crash into Jupiter itself. And you're saying to yourself, Jupiter's a gaseous planet. What could go wrong? Well, let's see. You see that big black eye on Jupiter, or the many big black eyes on Jupiter? Well, that's many times the size, the Earth would easily fit into those markings. So if the millions and millions of tons or megatonnage of the equivalent of TNT or nuclear explosions could happen on Jupiter because of the comet impact, the same energy as like many nuclear detonations, you could only imagine one of these comets impacting the Earth would be definitely a life-changing event on the Earth. So I had to mention this because we're very fortunate tonight to have on this Zoom meeting, and we'll talk a little later, David Levy, who was the co-discoverer of Shoemaker-Levy. And this is one of the most incredible comets that ever was in the news, because the summer of '94, for that 1 week, everything was all about SL9 and the impact on Jupiter. And I was fortunate to be photographing the landing of the Space Shuttle Atlantis in Florida the week that this happened. And while waiting for the shuttle, I went that night to a telescope at 25-inch, and I actually saw these markings on Jupiter myself. It was just incredible. The Hubble was only able to see the bright flash from the side of Jupiter when these comets hit. And then as Jupiter rotated once every 11 hours, you could see the markings one by one on Jupiter with these fragments. So now let's move on to the star of the show, or let's just say not the star, but the comet in the sky. About Comet Neowise, also known as C2020 F3. Not exactly a sexy name for a comet. Well, here's a view from a few hundred kilometers up from the International Space Station. Here you can see Comet Neowise easily visible as the glow of the sun on the back of the Earth. Here's the thin atmosphere. This is a comet that everybody's getting to see, especially in the northern latitudes. Many times comets are not visible for us here in the northern latitudes, but let's say in Australia, South Africa, or under the equator. But this time we're the ones that are lucky, and we're getting a show not to forget. So Neowise, the comet formerly known as C2020 F3 Neowise, I guess that's like the purple rain star, formerly known as the artist when he was changing his name. So it's formerly known as that. It's now Comet Neowise, was discovered on March 27th by NASA's Near Earth Object Wide Field Infrared Survey Explorer, Neowise, mission, according to the space agency. A couple of tidbits: the Comet Neowise won't return to our skies for another 6,800 years, give or take. So you better get it while it's there. There is about 13 million Olympic swimming pools of water in Comet Neowise. Emily Kramer, a scientist team and co-investigator for NASA's Neowise at NASA's JPL lab, said during a news conference on July 15th. So that's a lot of water. Apparently it has twice the amount of water than a normal comet that usually gets studied. Comet Neowise has two tails that typically accompany every comet. A Neowise is about 3 million miles or 5 kilometers in diameter, which is a reasonably large but roughly average sized comet. It's rare to see something that's this bright, and because it's been putting on a really nice show for us. And the comet is traveling about 40 miles per second. That's about 144,000 miles per hour, or 231,000 kilometers an hour. So definitely getting a speeding ticket for sure. And have no fear, Comet Neowise will not hit the Earth, just in case you're wondering. So here's a view. When we think about our solar system, we really have to start thinking in 3 dimensions. Although here on Earth, when we look at the night sky, it really looks like a 2-dimensional wrapping all around us. But we have to think of objects in our solar system as 3D, and that most of the planets, for example, orbit essentially on the same axis or same plane. From our point of view on Earth, it's known as the ecliptic. But comets, well, they're orbiting in their own way. They go around the sun in an elliptical orbit, but this one, for example, is going pretty well above the solar system axis, down, or like, going from down and above as it's traveling away. So with this kind of geometry, it gives a certain point of view from our point of view here on Earth. And that's why you see the comet low on the horizon when the sun was rising. As the comet gets very close to the sun and swings around, this is where it's in the glare of the sun. But as it moves towards Mercury and then Venus, and actually towards Earth, where it passed the other day, its closest approach to Earth, the comet is lit up by the sun, and this is the best time to view it. But then as it leaves Earth and starts to fade away, not only is it getting smaller from our point of view, but it's going to get dim because it's not being lit up by the sun, the energy of the sun as much. So it's not sublimating its material as much anymore. So it's been a busy few weeks, even though we've been trapped and couldn't go out. About a few weeks ago, one of our members, Frank Tamaris, I don't know, he kind of gave me the bug because he sent out a picture of the comet, and it was an early morning. It was, I believe, 4 in the morning, just before the sun starts to rise, because summertime's difficult. The nighttime is very short, as you know. But nevertheless, he had a picture of the comet he took in his backyard in Laval, and it freaked me out. I said, "Wow, he's getting those pictures. That's amazing." Because we've heard so many about comets in the past. We get excited. There was some other ones this season that were supposed to be like Comet Atlas, if I'm not mistaken. We were getting excited, and then it fizzed out. And then all of a sudden, this thing comes, and it's a superstar. So they're very unpredictable in some cases. So here is a gallery from the past few weeks from our members. So these are real photographs taken from our members in no particular order. And I'd like to advise that if I'm missing anybody, it's with no malice. I tried my best to bring out in this little gallery collection as many photos from the past few weeks as possible. So if I'm missing one and you want to show it to everybody after the talk, we can screen share and be more than happy. So without further ado, here we go. This one from Mark Ricard is a wider field image of the comet. With absolutely no question, you could see the detail in the dust cloud being shed here and the ion trail. It's just incredible. To say that earlier, we have the ion tail and the dust tail. There's potentially a third tail, which is a sodium tail, which scientists are just detecting sodium in the comet Neowise, but it's very, very difficult to image. Hale-Bopp at the time too had a hint of a sodium tail, but generally speaking, you see the two parts of the tail. Detlev Schmalhaus also took an image of the comet with tracking and a small telescope, and this is a gorgeous example of that. You can see the ion tail as well as the dust tail. And because the comet's an ever-changing thing in the way it's rotating in the night sky, for example, and if it's higher or lower, and the material that it's shedding, the comet appears to be, well, it appears to be different almost every time we look at it. This ion tail wasn't really too visible just a few weeks ago, and now there was the fanning of the dust tail as well. It was more of pretty well like an exclamation mark in the sky. It was like pretty straight. So it's really been evolving over the past few weeks. Here, Mark Milas, here's a beautiful shot of the comet. Carl Jorgensen took a picture of the comet not far from where he lives, actually very close to where he lives. And so you don't have to go all the way out in the deep dark sky to have some nice results as shown by Carl. So this is a nice variety from all around our members here in Montreal, taken from, let's say, a dark sky like an hour away, all the way to literally their backyards. And this is a good example of that. Here's Benchu's example, a stunning very early morning comet rise over the city of Montreal, looking pretty well northeast-ish, northeast. And then later on, a much deeper image of the comet in a very dark sky. And you could easily see the tail shedding its material, like the comet tail and the ion tail. It's just so beautiful to see this. So Benchu had actually animated the tail rising over the city, taken in the Nuns Island area from a friend's balcony, if I'm not mistaken. Just incredible. The only catch is that the comet's a little low on the horizon, so you have to be careful with where you plan to view these things. Maury Portnoff also took a stab at it and has a very nice result. It's just so ethereal to look at this. It's really amazing. My friend and my co-roomie took this picture last Friday when we went out, and it was a very nice night. And he was just simply using a simple DSLR camera with not much magnification, and this is the results you can get. It's pretty amazing. Using stacking software, you can reduce the noise in the image and bring out the detail. Well, here's some results. The one on the left is from Friday with minimal stacking. That's a close-up taken with my 71mm William Optics refractor, and I was tracking with the Ioptron Skyguider Pro. And last night, not to be outdone, On the right is one frame of a whole bunch of photos that I took, and you can easily see the ion trail. This photo is not processed. It's just pretty well the JPEG. And I had a bonus, either a little meteor pass through or a satellite. There were so many satellites crisscrossing the sky every time we go out. It's just incredible. A lot of traffic up there. So especially satellites that are reflecting the sunlight because the comet just became visible just shortly after the sun set, about an hour later. So now I'm going to share a little video that I took, and I hope this works. There you go. So that's a video that I took of the frames. The clouds were passing through, but I thought it kind of looked really nice with the clouds passing through. You can actually get a sense of what the sky looks like. Karim has taken a gorgeous comet photo. Many people are not, you see, like mentioned earlier, people are taking close-up images, like Karim mentioned, of the comet, the nucleus, the tail, and other people are taking wide comet shots, especially with foreground objects. For example, here at the waterfront in St. Anne de Bellevue, if I'm not mistaken, Karim and Karima and his son Elias, I believe, were taking these images. And look how beautiful that composition is with the tree. It's almost like the tree is ready to catch the comet, like a baseball mitt or something, just waiting to catch the comet in the sky. I just love the rich colors of the deep blue hues with the warm colors. This was in the evening last week. Frank Tamaris brought us out to a place called Belmont Park. For those living in Montreal, growing up in the 70s when I did, there used to be an old amusement park called Belmont Park, which now just became a waterfront park with condo developments. Nevertheless, it was a great opportunity to try to see Neowise 2 Tuesdays ago. And this is one of the photos that Frank took the other day, which is incredible because it shows that warm glow from the setting sun and the beautiful comet starting to appear in the sky. Gerald Mackenzie also has this beautiful, very wide shot of the comet. You can see all the lights down here with the reflection in the water, but you see the beautiful comet here amongst the whole sky. So I'm going to back up just to make sure I didn't miss any. Yeah, I believe that's it. Okay, so there are many, many more examples. And of course, not to mention that on the internet, there are thousands of comet pictures from all around the world with beautiful compositions. I just wanted to showcase what was taken here locally. And in many cases by nothing more than just a simple camera and tripod that most people have. So you don't need fancy tracking equipment or telescopes to do this. So before taking photos of it, what if you don't want to do that and you just simply want to observe Comet Neowise? Not to throw a whole bunch of data and things, but these are screenshots that someone had sent me earlier. Right now, we live in the age where there's an app for that, right? There's an app for this, an app for that. Well, there's apps for looking at the comet. And on your phone, you can actually see where you can expect in the night sky to see the comet at any given location at any given time. And for example, a software program which is free called Stellarium, and it's also on the phone as an app. On the phone, it automatically has the comet loaded, and if you have an older version of Stellarium for your PC, there's simple instructions on YouTube, if you just Google it, on how to install, and thanks to Detlev for this, on how to install the math app, or not the app, but the coordinates from NASA that go into Stellarium that actually help calculate where you'll find Comet Neowise in Stellarium. So here's a view, so that over the next few weeks, although the comet is rising from when it started, is also going to start to fade away and gets less visible as it's moving, pulling away from the sun, obviously past the Earth and on the way, towards Mars, Jupiter, and so forth. So I'd say that right now, is absolutely a critical time if you want to see Comet Neowise. I know the weather's been poor or cloudy. Last night was mostly good. This Friday is the next time that it looks like it could be clear, but any chance you can get, if you can go out in the evening, and I'd say around 10 o'clock in a reasonably dark area, you'll see Comet Neowise, and especially by 10:30, 11, you'll see it naked eye for sure. You have to start, even in a dark place, it's not exactly in your face. It's a very bright comet, especially with binoculars, but you have to give your eyes a chance to dark adapt and then to really let the sun set. Because we're in the summertime, it takes a while for the sun set. We have astronomical twilight. And then once you see the comet, even in binoculars or a small telescope, or if someone points it out for you, it's hard to unsee it. It's like once you see it, it's there. You're not going to lose it again. And it's quite large, actually. So last night, for example, it was just under Ursa Major, or if you're looking at the Dipper, the bowl of the Dipper, just essentially two widths of these, the two stars at the bottom. If you take that length and go just down, this is where Comet Neowise was here on July 21st last night. So it's moving pretty fast. And as you see in some of the images, when we even wait about an hour between, you'll easily see the stars move in relation to the comet because it's traveling so quick in the point of view of the background of the stars, which obviously are so much further away. So this week and early next week are the prime time for the comet. After that, it's starting to fade fast. So do yourself a favor, go out, even if you're in the suburbs, make a good effort to try to see the comet, because this one's not coming back in many of our lifetimes, that's for sure. Thanks to Karim for forwarding me this, but this is a plotted light curve of the comet. And as you can see right now is about the height of the brightness for the comet, as it will start to fade quickly as it pulls away from us. And it's not only is it getting further away from us physically, but of course it's not going to be as bright because the sun's not heating it up as much anymore. So this program Stellarium, when I looked it up for tonight, for example, at 9 p.m. Eastern Standard Time, looking northwest, northwest essentially, you'll actually see where Comet Neowise is. It's right here, just underneath the bowl of the Big Dipper. You'll find it underneath. And later on, when it gets darker, the comet becomes much more visible. As the night moves on, though, the comet does start to sink lower into the sky. So if there's murk, clouds, or just haze, sometimes later in the evening, the comet starts to disappear a little. So I'd say 10 to 11 is the sweet spot for looking at the comet at its most contrast, for taking photos as well. So how to photograph Comet Neowise? So you must think, you're looking at all these great photos and videos and these things you see all over the internet saying, I want a piece of that too. I want my souvenir. Well, I'm going to show you how to do that. First of all, you don't need very fancy equipment. Most of us have modern cell phones, which are many more cell phones today are becoming very light sensitive. So that's one way of doing it. And many of us own simple point and shoot DSLRs or digital point and shoot cameras. What's important with the camera, though, is if you can take a setting called bulb or time setting. So to get the maximum amount of light from the comet, even though most modern cameras today are very sensitive to light, just like in the old film days, the longer the exposure, the more detail you get, but also the more washed out it can get. So I've been personally experimenting with just the camera lens on my DSLR, and I'm tracking it, but you don't have to. If you have a wider lens, you don't have to track it. It could just be on a stable tripod, just pointed at the area you want, especially with a foreground that you would like a mountain, lake, or even a cityscape. By taking a photo, let's say for 10, 15 seconds, you will get the comet to appear very easily. But as one of my friends last night, Karima, discovered, it's not quite easy to focus on this thing because you're trying to focus on something in the dark And there's a lot of trial and error. You take a photo, review your image, zoom into the image if your camera allows, see if you're on focus, if the background stars are as pinpoint or tight as possible. Keep in mind that most lenses, when focused to infinity, are past infinity or not at true infinity. So don't rely on the camera's infinity focus setting. Use manual focus. Do not use autofocus. Autofocus will simply not know how to handle this. But with some trial and error, and then you take a photo, move the focus ring, take another photo, see if the stars are getting blotchier or tinier, and then you're going in the right direction. That's how you can focus. Also, for some more advanced amateurs, there's something called a Batinoff mask, which is essentially a plastic circular mask that goes over the lens of your camera lens or telescope. And these lenses have slits that are cut out in a triangular shape. And then when you take a photo, the stars have spikes in them, diffraction spikes. And when you're in focus, the three spikes crisscross each other in perfect symmetry. The middle spike is perfectly in between the outer spike and the inner spike. You know you're perfectly focused. And that's how I focus most of my stuff with good success. Now, if you want to get a little more serious, and it's noteworthy to know that you can take pictures of the comet with a cell phone, but try to hold it as steady as possible on a night mode, or let's say a fireworks mode, because that's going to allow your cell phone, in the professional settings of your cell phone, to allow you longer exposures. But keep in mind, like I mentioned earlier, especially in more light polluted areas, the longer the exposure, the more washed out the background is. But you want as much detail as you can get. So just experiment and have fun. It's your own personal souvenir of this beautiful comet event. For the more challenge, well, people that are craving a challenge, like myself and many others, you can actually photograph the comet with a telephoto lens. It's essentially, a small telescope at that point, on a tracking mount that you polar align, and essentially you point it to the comet and you just fire away and take many photos, and use Deep Sky Stacker as a free stacking software to cancel out the noise as much as possible and tease out details in your image using Photoshop or GIMP or any other image processing software. So you can go from the really simple setup with the camera to the setup that Detlev Smallhouse here has, using an ASI Air with auto guiding and tracking on a 72 millimeter telescope here, and his DSLR. He was able to take some beautiful up close images of the comet with the tail, but with the green head as well, the coma. It's really beautiful. So you can go all out with this, and I've been trying to do that myself. I was lucky last night to take images with an 85 millimeter Rokinon lens, which many people have, with my Sony camera. It was tracking it, but because it's so wide field, the stars are not as trailed, because don't forget that the comet is moving faster in our point of view than the background stars. So if we're polar lining and we're shooting so that the stars are pinpoint in our tracked images, the comet will appear a little smeared, actually, even within 10 seconds if you're not careful, if you're zoomed in too much, or if you have too much power with a little refractor. So experiment, have fun, but don't forget to look up with your naked eye, or if friends allow you to view through an eyepiece. So if you have your own scope, to look through. I mean, we still practice social distancing, but if you bring your own telescope, you can look through the eyepiece and get a beautiful view for yourself, which I did last night, and it was really amazing. Don't expect to see the ion tail that easily, though, because that's something that's hard for the human eye to actually see. The sensors of cameras pick it up easier. Well, I'm going to bring my chat to an end tonight, my talk, and I'm going to leave it open for an all-in-one session where everybody can jump in. So if, I think, Karim, if you can unmute everybody, and I'll stop sharing my screen.
Rather than unmuting everybody, let's unmute one at a time as people ask questions to make
Sure.
it easier. There is a question in the chat, but it's a little bit Toronto specific. It's Larissa's asking if we know if it's possible to view it within the city of Toronto and where. And do you have an answer, or shall I give one?
Well, you can add to it. I'll add. I'll start off by saying thank you for tuning in. I really appreciate it. Um, just like Montreal, Montreal is one of the most light polluted cities per capita in North America, and I'm sure Toronto is no exception. So for starters, it is possible to see the comet in light polluted areas, especially if you can get away from the core of the city and if you can get just to the outskirts, maybe near the waterfront. The key is that you have a horizon that allows the comet to be visible, because a lot of skyscrapers or homes or apartment buildings will obscure the image of the comet or the view of the comet simply because it's only 9 to 11 degrees above the horizon. So that will be a little challenge. So you have to make sure you have an open view to the northwest or northwest. More and more now to the northwest as time's going on. So if you can see, let's say, a third the way from the bowl of the Big Dipper down to the absolute horizon, that's where you're going to see the comet in the next few days, moving more and more to the west as time goes on. So it should be visible, but have patience. It's not going to jump right out at you. Even in the dark sky, I'd say about 10 o'clock, it's not exactly in your face. And then slowly but surely, as the night goes on, you get more accustomed to the dark sky and your eyes get sensitive. You can start to see the comet. So give it a try. I was shocked that Ben Chu, one of our members, was actually able to take a picture of the comet over the city of Montreal from his point of view in very light polluted area. I didn't think it was possible, so I didn't even bother. And I got the fever from this. So thank you, Ben. I don't know if Karim, would you care to add anything else?
There's been some excellent pictures taken also in Old Port and up on the top of Mount Royal. In Toronto, I would actually suggest if you can go north of the 401 to like Bayview Park or somewhere up towards Barrie or Brampton, you'll have the best view because you'll be away from the lights of the 401. And that really is going to be your stopping point in Toronto for your view to the northwest. But I know a few people in the city in Toronto have been taking pictures, even from down on Center Island with the lights of Toronto right in your northwest view. They've taken some amazing pictures of Neowise. So does anybody else have a question they'd like to ask David?
There, thank you. David, that was a wonderful talk.
Thank you kindly.
I really did enjoy it. I really like the idea that you also talked about other comets like Hyakutake and Hale-Bopp and SL9. But I'd like to introduce you to someone who I wish could be here now, the poet Gerard Hopkins. And his poem, I Am Like a Slip of Comet, really is all about Neowise. And with your permission, I'd like to sort of digress a little bit and tell you how this poem really describes Neowise. I am like a slip of comet, he's like Neowise, scarce worth discovery in some corners seen, bridging the slender difference of two stars. But when she sights the sun as Neowise did, she grows and sizes and spins her skirts out, while her central star shakes its cocooning mists. And so she comes to fields of light. Millions of traveling rays pierce her. She hangs upon the flame-cased sun and sucks the light as full as Gideon's fleece. But here we get to the point where he predicts what's going to happen to Neowise, and I think he's right on that. But then her tether calls her. She falls off, and as she dwindles, sheds her smock of gold amidst the sistering planets, and then goes out into the cavernous dark, as Neowise will. And then he ends it, so I go out, my little sweet is done. I have drawn heat from his contagious sun, to not ungentle death, now forth I run. Hopkins was a poet, and a very fine one, but if he were living today, I'd put money on the fact that he'd be a member of the Montreal Center. Wow. And attending your wonderful talk.
Thank you kindly. And once again, I can't express how absolutely privileged and lucky that we are to have you not only serving on the board with us as the oh my God, I'm tongue twisted right now. But you're honorary president. But you know many of our members for many years, and you're absolutely the most preeminent, one of the preeminent Comet, passionate Comet hunters in the world. I mean, there's Comet Lovejoy, there's many others, but as more and more machines or digital systems are taking over, people are still finding comets once in a while the old-fashioned way. You know, they earn it, like they used to say in the commercial in the 70s. But it's just such a privilege. So, and like I mentioned earlier, this is a year that I think we're not going to forget for the rest of our lives, mostly because it's not been such a nice year for many people, and the world's going through a tough time. But what a lovely little kiss from the sky that we got in the past few weeks. What a treat. And boy, I can't wait till Friday if we can go back out again. Damn those clouds.
I'll also mention that David gave one of the best quotes that we've had for comets that we've been using when people ask whether or not they'll be able to see the comet on Friday or next week, or how long the comet will be around. And David, do you want to share it since you say it so well?
Yeah, I do. I will say it. Comets are like cats. They both have tails, and they both do precisely what they want. And Neowise has shown us already what it wants, but it too can surprise us, and probably will as it heads out.
I will say, having gone out searching for Comet Atlas earlier this quarantine and seeing a faint fuzz barely through my telescope with my daughter and thinking maybe that's the comet, I think I might have seen it. This time around, I know I saw the comet. Like it's clear that's what I'm seeing.
Yeah, there's no question about it. It is a little hard to see at the beginning, though. Like on Friday, Paul and I, for example, where is it? Where is it? We couldn't see it. Then Mark Ricard, oh, I got it in the camera. I got it, or I got it in the binocular. I can't see it. I'm blind. What's going on? And then once you see it, you can't unsee it. It's there. And as the night gets darker, it's just more contrasty, and it's beautiful.
What's interesting about Neowise is that it's not there. I don't see it. Oh my.
Oh, yeah.
It comes out there and it opens itself like a curtain, and it's just magnificent.
We found it incredible at Saint Anne de Bellevue, just here near John Abbott, where our library is. My wife, my daughter, and I were down there, and we were looking for the comet. We were hoping to see it. I see Dee Dee here. She was down there with us, and there were a few others. And we were searching, and all of a sudden you could see it just above the tree. And Sandra and Dee Dee and myself and a few others, we were just exclaiming, because the fact that you could see it naked eye with a big light right there beside us, and the city lights all around us, and a highway in front of us, and you could still make out the core, the coma, the tail, and it popped. You know, even before we could see it, you could see it in camera pictures with, you zoom in and you can just see a fuzz, and it was nice. And with binoculars, it's just amazing. But the fact that you could see it with your naked eyes, and that's something that I missed out in the late 90s when Hikatomi and Hale Bopp were there. I wasn't able to actually catch them. And so being able to see this one was just, it was inspiring.
I'll tell you one thing, that if you're lucky to have a DSLR with what's called live view, my Sony camera happens to have a live view. And what that simply means is that what the camera is viewing for a long exposure, it actually displays it real time in the rear screen of the camera. And as the night goes on, I actually can live focus on Neowise. It's visible in my camera, very bright, and I can actually move the focus in and out on the comet head itself, the coma, and the nucleus itself. So that's how you can focus, and it's so bright you can actually see it in the back of the camera, like live.
Would anybody else like to share some of your observing experiences of Neowise before we stop the recording and just enter into casual conversation? I see Ben has arrived and he can tell us all about how amazing it was at Guest Bay.
Hi, Karim. Yeah. Well, actually, I was there. I came back like at 8:10, so I was here like for most of David's talk, and it was a great talk. Thanks, David.
Thank you.
And yeah, I just want to echo what David and David talk about. Nowadays, it's more the machines discovering the comets, because probably you guys are not aware that for Chinese, the whole language needs a name for this comet. It's like Neowise is not a proper Chinese name to publicize. So there's a big debate, because before it was so easy. Everybody someone found the comet, so there's a name, an English name, there's Chinese translation by sound. It's pretty easy. But now we have Neowise, so how do we translate it? If we translate by sound, it means basically nothing. If we translate by all the big words all together, because Neowise are the acronyms, it will be a very mouthful, long name. And now, finally, they decided to translate as something like a new wise, new and wise, something like that. So yeah, that's an aspect that when I heard about this, and people were talking about they have different opinions on this translation. I was just saying I miss the old days that people find comments and things are much easier for the translation, everything.
That's an interesting point.
There's a hand up by Matai. He has a question.
Go ahead.
Yeah, can everyone hear me? Sorry.
Yes.
No, I just wanted to add on this because I went on the 17 on Montreal at the Saint Joseph Oratory, and so my equipment is not too complicated. I have like a 24 millimeter Sigma and a DSLR, so I could see it there first. But like with the naked eye, it was a challenge. There was a bunch of people there like trying to catch it. Most of them locals, I guess maybe a few tourists. And at some point I got it and it was like, oh, where is it? I cannot see it. And then all of a sudden the kid was like, oh, look, I can see it with my eyes. It's very beautiful. So it was quite an experience.
So yeah, it's the same feeling that I got last week near Belmont Park, looking towards Laval. We were looking and looking, and I didn't realize it was higher up in the sky than we expected. I didn't think it would be that high. And then my friend Frank Tamaris, he spotted it first. And then Paul and I, we're blind. We're looking, where is this? Oh my God, there it is. And then once you track on it, you see it, you know. Everybody says that you could use averted vision where you don't look exactly at it and it's a little brighter. But believe me, now that this comet's bright, you don't need averted vision at all.
Russell is going to share a picture he took last night at Benny Park.
Thank you.
Oh yeah, thanks. Thanks, David. That was really cool. I learned a lot. Oh, just a second. I got to put the zoom on here. I'll share this picture. So I'm still learning how to do all this stuff. Can you see 3 pictures?
Yep.
Yes.
So this is taken with, I guess, similar to yours, David. I got an old Canon XCSI 450D, and I took some pictures and I tried to process it in different ways, and I'm still learning. But I was like, oh, that's pretty cool.
I can see the ion tail. That's
gorgeous. I was
Yeah.
surprised. I hadn't looked at other pictures, and I wasn't expecting to see 2 tails. But yeah, there were.
Yeah, absolutely. It's beautiful.
Yeah, it was really nice. And I took it from Benny Park and NDG, and I set up my tripod and camera, and within at least maybe 10 seconds, I had 4 people swarming around me asking, "Oh, qu'est-ce que vous faites, monsieur? Vous prenez les photos de la comète?" And then, okay, I haven't even set it up yet, guys. Just hang on.
Well, I'll tell you, Benny Park's not too far from where I live in Côte St. Luc, and I can appreciate how light polluted the area is. And it goes to show you that with a little patience and time, look at what you can see. Even in the heart of the city, you can get results.
And I see Larissa is still on. Larissa, Benny Park is about as dark as the area around the Ontario Science Centre in Toronto. So you're looking at a fair amount of light pollution, and Russell was still able to pull out this much detail.
Yeah, I found a spot that hid the nearest streetlights. There was a tree. I put a tree behind it, and then I shot over a bush, and then it was fine, and it was good enough.
It's actually amazing how just if you can find a location that just blocks out a few of those really, really bright lights, it's, especially now that the comet's getting a little bit higher, it's almost enough to give you that semblance of darkness.
Yep.
Yeah, Frank used the tree last week with this point of view of the camera to block out an annoying park light.
I look forward to the day when we can safely start doing members outings again and start to actually get out and observe at the Morgan Arboretum or at John Abbott Field or anywhere along there. It's needed.
Yeah, sorely, especially that Mars is coming and many other goodies, like stuff to look forward to. I mean, this astronomy, it's what's keeping me sane during my unfortunate time right now, because I'm not at work right now, and it's been a really stressful time, and this astronomy is my escape hatch, believe me.
So I'm going to ask David to stop the recording, and we'll all thank him, and then we'll continue our conversation. Thank you so much, David. That was fantastic.
Thank you.